All right, so Unit 2, Day 1, we're going to be solving equations and inequalities. Now, to solve an equation, 1, we perform any distribution shown in the equation. 2, combine any like terms in the equation. So if there are like terms on one side of the equal sign, combine those values and do the same to the other side if you need to. Number 3, move the variables to one side of the equation. A, it doesn't matter which side you choose. B, usually you'll need to add or subtract to move the variable or variables. You must have your variable term on one side and your constant term on the other. Number 5, finish solving the equation by isolating the variable. Usually just have to multiply or divide to finish solving. So let's take a look at number 1 here. We have this equation. Notice that we can apply the distributive property on both sides of the equal sign. So I'm going to take this 3 and distribute to each term. And then do the same thing for -7. Distribute that to each term. So we have 3 times 2x, that's 6x. And then 3 times 5 is 15, so plus 15 equals, so -7 times x is -7x, and then -7 times +9 is -63. So what I'm going to do now is add both sides by 7x. Okay, so I have 6x plus 7x is 13x plus 15 equals -63. Then I need to get that 13x by itself, but that positive 15 is in the way, so I'll subtract both sides by 15, and that is going to give me 13x. These two numbers will go away, so I have 13x equals -63 minus 15. I'm starting negative and then tacking on more negative, so I have -78. Then I will divide both sides by 13 here. So I have x equals -78 divided by 13 is -6. Number 2, so we have 3p minus p minus 9 equals 2 times the quantity of p plus 5. Now, one thing that I want you to note is that since there's a negative in front of the parentheses, that negative actually has a number right next to it. It's actually 1. So you have -1, which I will distribute to each term inside the parentheses. And then we're going to do the same thing for 2 here. We're going to distribute that to each term. So I have 3p, and then -1 times p is -p. -1 times -9 is +9, equals 2 times p, that's 2p. 2 times +5 is +10. Notice that we can combine the like terms on this side of the equal sign. So I have 3p minus p. So that's going to be 2p plus 9 equals 2p plus 10. There's nothing to combine on the right-hand side of the equal sign, so now I can go ahead and proceed. Let me go ahead and subtract both sides by 2p here. And look at that, 2p minus 2p, that cancel. So I have 9 on the left-hand side of the equal sign. And then this 2p minus 2p on the right-hand side of the equal sign will cancel out. So I'm left with 10. So look at that, we have a statement. So right here, this is a statement. And you're going to evaluate the statement. So statement is 9 equals 10. Ask yourself, is that true? No, it is not true. So 9 is not equal to. So the symbol means not equal to. So whenever you have this situation here, if a number is not equal to another number, this is a false statement. So we need to make sure that we write no solution. So what this means is that any p-value that I plug in to this equation here, the left-hand side is not equal to the right-hand side. So if I plugged in 1 for each p, once you use your order of operations and figure out the left-hand side and the right-hand side, you'll notice that they're not going to equal no matter what p-value you put in. So that's what it means, no solution. All right, so let's move on to 3 here. We have 2/3 x minus 1 equals x plus 12. I do have a trick to remove that fraction, but first what I want to do is I'm going to add both sides by 1 here. So I have 2/3 x equals x plus 13. I want to get rid of this 3 in the denominator of this fraction. So in order to get rid of that, I'm going to multiply everything here by that number that appears in the denominator. So since there's a 3 in the denominator, I'm going to multiply everything by 3. And then I'm going to distribute the 3 to each term in this current equation. So I'm looking at 3 times 2/3 x. That's basically 6 over 3x, or 2x equals 3 times x, that's 3x, and then 3 times positive 13, that is 39. So now I can go ahead and subtract both sides by 3x here. So 2x minus 3x, that's going to be negative 1x equals 39. We're not done yet. Remember, we're solving for x, not negative x. So I will divide both sides by negative 1. So x equals negative 39. That is your answer for number 3. Number 4, let's go ahead and apply the distributive property to each term. So I have 5x, and then negative 2 times 4 is negative 8. Negative 2 times positive x is negative 2x equals negative 11. And then we have positive 3 times 1, that's plus 3. Positive 3 times positive x is plus 3x. Let's take a look at any terms that we need to combine. I notice that we have to on the left-hand side of the equal sign, so I'll combine the 5x and the negative 2x together. 5x minus 2x is 3x minus 8 equals, and look, we have some constants on the right-hand side of the equal sign, so negative 11 plus 3 is negative 8. Plus 3x. So I'm going to subtract both sides by 3x. And then notice that those cancel. So we're left with negative 8 equals negative 8. Look at that. We have another statement here. The left-hand side is equal to the right-hand side. Negative 8 is equal to negative 8. So we can say that this is a true statement. If it is a true statement, our answer is all real numbers. And the reason our answer is all real numbers is because whenever I plug in an x value, it doesn't matter what x value you use, the left-hand side will always equal to the right-hand side. So if you plug in 1 or 2 or 5.675, the left-hand side is equal to the right-hand side once you use your order of operations. You'll see it, okay? All right, let's move on to number 5 here. We have 1/3 times the quantity of 2x minus 7 is equal to 4. Notice that we have a fraction in front of the parentheses. What I want to do is get rid of the fraction. And how we do this is by multiplying both sides by the reciprocal of that fraction. So if it's 1/3, then I'm going to multiply this by 3 and this by 3. So really I'm multiplying the 3 and the 1/3, and that will cancel, and that'll leave me with 1. Or you can say 2x minus 7. And then on the right hand side, we have 4 times 3, which is just 12. So doing this process saves me so much time and effort, because look at what we have here. We have 2x minus 7 equals 12. I can go ahead and add both sides by 7. And we're left with 2x equals 19. And then we can go ahead and divide both sides by 2. And I'm left with x equals 19 over 2. Or you can rewrite this as x equals 9.5. Either answer is acceptable. Number 6, we have 2 times the quantity of x plus 4 minus 5 times the quantity of x minus 3 is equal to 32. So I'm going to go ahead and distribute the 2 to each term inside of this parentheses. And then we have a negative 5. I don't want to circle just 5. Since there's a negative sign, let's go ahead and include that and then distribute to each term inside of this parentheses. So I have 2x plus 8, and then negative 5 times x is negative 5x, and then negative 5 times negative 3 is positive 15 equals 32. Make sure that you're checking your work with the calculator because sometimes we can make that arithmetic mistake. So let's go ahead and avoid that. Okay, so on the left-hand side of the equal sign, I can combine the 2x and the negative 5x, and I can combine the positive 8 and the 15 together. So 2x minus 5x, that's negative 3x, and then positive 8 plus 15, that is positive 23, equals 32. Subtract both sides by 23. I have negative 3x. Equals 32 minus 23 is positive 9. Then I divide both sides by negative 3. So x equals 9 divided by negative 3 is negative 3. So that's your answer for number 6. All right, flipping to the back side of the notes. We're going to go ahead and solve inequalities, but before we do that, here's some important things to remember when solving inequalities. When we have a less than sign, we typically shade to the left, and when we have a greater than sign, we shade to the right, and those two things are open circles. We do not include that number. And then when we have a less than or equal to sign, we typically shade to the left. And then when we have a greater than or equal to, we shade to the right. And those are closed circles. We do include that number. So here are some important information when solving inequalities. If you multiply or divide by a negative number, you flip the inequality symbol. So let me go ahead and give you an example on what that looks like. Let's say I'm comparing two numbers here. Let's say I have negative 5 and 2. So comparing these two numbers, what is the largest number? Well, it's going to be 2. So negative 5 is less than 2 because 2 is the largest number. But if I were to divide by a negative, let's say I divide both sides by negative 1 here. Negative 5 divided by negative 1 is positive 5, and then 2 divided by negative 1 is negative 2. So if I'm comparing these two numbers, what's the largest number now? Well, that's just going to be 5, right? So 5 is greater than negative 2. So we went from less than to greater than because we divided by a negative. Now that also applies to multiplying by a negative. So when we multiply by a negative number, we also flip the sign. So for the next bullet point, if the variable is on the right side of the inequality after you have solved the problem, flip the entire problem. So what that looks like is this. Let's say you have 5 is less than p. Well, I would rather have the variable first, then the inequality, and then lastly, the number. So it would look like this. P is greater than 5. The less than sign changed to the greater than sign. When I rewrote this problem, it doesn't really change much because this symbol is still going to follow the P. So notice that when I wrote P is greater than 5, the symbol is still following the P here. So I would rather have you write the variable, then the inequality, then the number afterwards, okay? Now, If the variable cancels out while solving and you are left with a true statement, the answer is all real numbers. So what that looks like is if you have something like p plus 8 is greater than p plus 7. Well, if I subtract both sides by p, I'm left with positive 8 greater than 7. And I'm looking at this statement, and it turns out to be true because 8 is greater than 7. So if you have a true statement, then it is all real numbers. So what this means is that whatever you plug in for p, the left-hand side will agree with the right-hand side. However, if the variable cancels out while solving and you are left with a false statement, the answer is no solution. So if I said p plus 7 is greater than p plus 8, and I subtract both sides by p here, I have positive 7, which is greater than 8. So this is my statement, and we all know that 7 is not greater than 8. So this is a false statement, and when you have a false statement like this, we say that this is a no solution answer. Which means that whatever you plug in for p, the left-hand side will not agree with the right-hand side. Alright, so let's go ahead and solve linear inequalities. Now when we're solving inequalities, it's like solving equations. But this time we have inequalities involved, and we need to make sure that we keep these rules in mind. So, number 1, negative 5x plus 75 is greater than 125. I'm going to go ahead and subtract both sides by 75. And I'm left with negative 5x is greater than 125 minus 75 is 50. And then I'm going to divide both sides by negative 5. So I have x on the left-hand side of the inequality. And then I have negative 10 on the right-hand side of the inequality. But since I divided by a negative, I need to flip the sign. So then if I look at this greater than sign, because I divided both sides by a negative, this becomes a less than sign. So I have x is less than negative 10. So let's go ahead and graph and then write our interval notation. Negative 10 is the main character. Since this is a less than sign, we have an open dot. And I'm going to go ahead and think of some x values that are less than negative 10. So negative 11, negative 12, negative 13. So I'm basically shading to the left. So then to write my interval, we read from left to right. So it starts from negative infinity to negative 10. And then typically when we have negative infinity or positive infinity, they're not included, so they get a regular parentheses. And then the negative 10 is an open dot, so that means we have a regular parentheses to close the interval. Okay? All right, so let's go ahead and take a look at number 2. So number 2, I have 4 times the quantity of 4a minus 5, which is less than or equal to 8 times the quantity of 5a minus the difference between 3a minus 7. So what I'm going to do for number 2 is I'm going to apply the distributive property. Notice that I can go ahead and distribute the 4 to each term inside of this parentheses. But when I look over here, we have a lot going on. Now, I know that we have this 8 in front of this bracket here. But we have stuff inside to take care of. Notice that we have a parentheses here. So I'm going to take care of this stuff first before I distribute the 8 to each term. So remember, we have a negative in front of the parentheses here. This negative is actually a negative 1. So then let's distribute the -1 to each term. So I have what? I have 4 times 4a, that's 16a. 4 times -5, that is -20, which is less than or equal to 8 bracket 5a. -1 times 3a is -3a, and then -1 times -7 is +7. And then look at that, we don't have any more parentheses. Now notice I can combine the like terms inside of this bracket here. So 5a minus 3a is 2a. So let me go ahead and rewrite 16a minus 20, which is less than or equal to 8 bracket 5a minus 3a. We said that's 2a plus 7. And since I'm pretty much done with the stuff inside of the bracket, I can go ahead and apply the distributive property here. So I'll distribute the 8 to each term. So I have 16a minus 20, which is less than or equal to 16a plus 56. Then I'm going to go ahead and subtract both sides by 16a. And I have -20, which is less than or equal to 56. Look at that. We don't have any variables. We have a statement. So evaluate the statement and tell me it's true. -20 is less than or equal to 56. That sounds about right. So this is a true statement. And since this inequality is true, the answer is all real numbers. Okay? So if I were to graph this line, it would be all the possible numbers in the real number system, going from -infinity to +infinity. So when we're reading this left to right, when writing our interval, we're starting at -infinity to +infinity, and then we close them with regular parentheses. Number 3, we have 5 times the quantity of 1 minus y, which is less than 4 times the quantity of 2 minus y, minus 3 times the quantity of 1 plus y. So I'm going to go ahead and apply the distributive property. And I have 5 minus 5y less than 8 minus 4y minus 3 minus 3y. I can't combine any like terms on the left-hand side of the inequality, so I'm going to go ahead and move on to the right-hand side. I see 8 minus 4y minus 3 minus 3y. I can go ahead and combine the two constants here, so 8 and -3 can be combined. And then we have -4y and -3y. So 8 minus 3 is 5, -4y minus 3y is -7y, and then I can go ahead and rewrite the left-hand side of the inequality. So I'm going to go ahead and add both sides by 7y. So I have 5 plus 2y, which is less than 5. And now I'm going to go ahead and subtract both sides by 5. And I'm left with 2y, which is less than 0, because 5 minus 5 is 0. Now, I'm going to go ahead and divide both sides by 2. I have y is less than 0. So, if y is less than 0, we have an open dot, and we're going to be shading to the left because -1, -2, -3, and so on are less than 0. And then to write my interval, we read from left to right. We're starting from -infinity, and then we're ending with the 0. So both of them are going to get a regular parentheses because when you have a negative infinity or a positive infinity, we use the regular parentheses for that one. And then 0 is an open circle, so that gets a regular parentheses too. All right? Okay, so just remember one thing on your homework is that whenever you have something like this, if you have like 5 less than p, make sure that you flip the entire problem so that the variable is first, then the inequality, and then the number afterwards. So if we look, we did that for number 1 here and number 3. We don't want negative 10 is greater than x to be our final answer. We want to make sure that the x is first, then the inequality, then the number right after that. Okay? All right, so that should be it for today's notes.